Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Aisyah binti Abdul Halim. So, for our title for this assignment is Principle in Identification of Human Remains Through Forensic Odontology. So basically, what is forensic odontology? Forensic odontology involves the proper handling and analysis of dental evidence for legal purposes, focusing mainly on the identification of human remains. It includes age estimation, bite mark analysis, and abuse investigation. A key aspect in dental age estimation, especially in juveniles, which aids in building a biological profile, is to narrow down the identity of the candidates. Identification is achieved by comparing antemortem and postmortem dental records, assessing consistency and inconsistency to confirm or to exclude a match. This article highlights the role of such comparison in identifying unknown remains. Since this is the unique and durable, they serve as a reliable evidence or suitable evidence in identifying individual and linking suspect to the crime scene. So, the objectives of this research is, first one, to explain the principles and methodologies behind identifying human remains using dental data. And the second one is to emphasize on comparison between antemortem records, which is dental records before the death, and postmortem, which is collected after the death. So the third one, the last one, is to access the value of unique dental traits, modern software, and involving technologies. So we go further for the postmortem data collection. So the goal of postmortem dental analysis is to establish a dental profile for comparison with the antemortem records, which is before the data before the death. So the initial observation, access, age group, presence of dental treatments or pathologies, and the condition and preservation of the remains. So the essential documentation includes dental photograph, radiographs. So what is dental photograph is its various views such as anterior, lateral, occlusal, and lingual. So for the radiograph, it's such as peripheral of the all teeth, including attitudinous. So the finding will be recorded in a postmortem odontogram, including teeth present and missing. So it will not if the loss was antemortem or postmortem. So the second is type of dental occlusion, arc shape and teeth alignment, evidence of trauma, surgery or pathology, and also dental applies and treatments such as implants, crowns or dentures. So next, additional imaging such as CT scans or surface scans. It will be used depending on the available antemortem data and resources. And although some factors can impair evidence, such as fire or chemicals, teeth are highly resilient and remain reliable for the
Hello, my name is Nurul and Akila binti Omar, and now I'll be presenting purpose and forms of antemortem data. Let's begin with the purpose of collecting antemortem data. The main goal is to reconstruct the individual's most recent dental condition using available records. These records may include written charts, photographs, radiographs, CT scans, and even 3D surface scans of the dentition. In some cases, retainers, aligners, or mouth guards can also provide useful information about tooth presence and alignment. However, this data does have limitations. For instance, medical imaging often fails to show the teeth clearly because of overlapping or superimposition artifacts. Next, written records can be subjective, sometimes incomplete or hard to interpret accurately. Then, photographs are helpful, but they only reveal the visible crown surfaces, not the internal tooth structures. And mouth guards may tell us which teeth are present or missing and give an idea of the dental arch shape, but they don't reveal information about restorations or root canal. Next, dental radiographs. This leads us to the most valuable source of antemortem information. Radiographs are considered the gold standard because they offer objective and detailed insight into the condition of the teeth. They allow us to see restorations, root canal treatments, and the alignment of teeth, which are essential when comparing to postmortem findings. In summary, although many different types of records can contribute to the identification process, radiographs provides the most reliable and comprehensive data, then making them the cornerstone of successful forensic dental identification. Now moving on to the comparison stage. The objective of this process is to determine whether the postmortem dental data of an identified individual matches the antemortem records of a non-person. The comparison is carried out tooth by tooth using both odontograms and radiographs. We assess a variety of features including dental anatomy, restorations, implants, orthodontic work, and any pathological conditions. Both visual and radiographic consistency are essential in building a reliable match between the two records. Types of matches and inconsistencies. During this process, there are three possible outcomes for each observation. Concordant findings mean there is an exact match, such as the same restoration in the same tooth with matching material and shape. The second one is reconcilable inconsistencies. These refer to changes that could logically occur over time. For example, a tooth may have been lost or threatened after the last antemortem record. The last one is irreconcilable inconsistencies. These are the differences that simply cannot be explained, such as reverse tooth development stages. If even one of these inconsistencies is found, the match is excluded. Last but not least, tools and expert judgment. To support this comparison, forensic odontologists use specialized tools like WinID, DVI system, and UVIS. These systems help to organize and rank potential matches based on encoded dental features. However, these tools are just an aid. The final decision always relies on expert judgment. The forensic odontologist carefully assesses both the consistencies and inconsistencies before reaching a conclusion. Depending on the evidence, the outcome can be a positive identification, a possible identification, a finding of insufficient data, or an exclusion.
Hi everyone, I am Atika Inshira and I will be presenting slides starting with key features used to identify human remains. For identification, the value of any consistent feature between postmortem and antemortem dental records depends on how unique it is. The more individual or rare the feature, the more useful it is for identification. Let's go through the six key features, which is first, restorative treatments. Restorative treatments like fillings, root canals or crown are custom-made and highly individuals. We compare the material, shape and location. Second, dental implants are visible in X-rays and often leave a distinctive pattern even if we don't know the brand. Third, orthodontic appliances such as braces can vary by brand, size and positioning, making them useful markers when compared across records. Next, we have dentures. These are also custom-made and sometimes labeled with the patient's name, barcode or even RFID tags. But to confirm identity, the fits with the jaw must also be checked. Anatomical traits include natural variation like crown or root shape, pulp chamber structure, the outline of sinuses and bone patterns. This can be especially important when no dental work is present. And lastly, there are additional tools like palatal which are unique ridges on the palate and remain stable over time. Lip prints or cheloscopy are also a form of ID, though they are rarely used today because DNA is more reliable. Moving on to slide 8, let's talk about the technology used in forensic odontology. First technology is comparison software. Comparison software helps match dental records from postmortem and antemortem sources. It's a digital tool that assists experts in narrowing down possible identities. There are three main programs, which is first is WinID. WinID is a free tool focused only on dental data. It generates rank match results and has been used in major disasters like Hurricane Katrina and 9/11. DVI System International is a paid software used by Interpol. It integrates dental records along with fingerprints, DNA and other evidence. It works with both paper and digital system, which is useful in the field. UVIS or UDIM is a web-based system created after the 9/11 attacks by New York's Medical Examiner. It allows image uploads and reassociation of fragmented remains, making it useful in both everyday works and mass disaster. And finally, AI and machine learning are being developed to identify dental features automatically from radiograph. This system aims to speed up identification and reduce human error, but expert analysis is still needed for a final conclusion. That's all from me. Thank you.
My name is Nurul Aisha Afika, and I will focus on two key aspects. The first one is forensic expert intervention. Forensic odontologists play a critical role in identifying human remains by comparing antemortem and postmortem dental records. According to the American Board of Forensic Odontology, there are four possible conclusions. First, a positive identification, where record match in detail with no contradiction. Second, a possible identification, when similarities exist but are not infinite. Third, insufficient evidence, when no enough data to conclude. And lastly, exclusion, when data is clearly inconsistently. Researchers like Stimson and Nielsen suggested a minimum number of matching features, 8 or even 12 for identification. However, more recent research, particularly by Arcana and Taylor, demonstrated that no fixed number of matching points is required. In fact, an identification can be made from just a few highly unique features or even a single distinguishing characteristic, especially in edentulous individuals like implant or identification process involve both objective and subjective elements. Objectively is the comparison of these and anatomical features. Subjectively, they must interpret whether differences between records are reconcilable or not. This decision-making process requires professional judgment, experience, and familiarity with dental version and pathology. To support the expert opinion, tools like Odontology are used. This program compares data features against a database of over 107,000 adult records. It helps estimate how common or rare a certain data pattern is, which strengthens the objectivity of the final conclusion. Second aspect is future directions. Forensic odontology is advancing with the use of digital 3D models. These are created through intraoral scanners and are replacing traditional plaster models. They are precise, easy to store, and increasingly included in clinical and antemortem records, making them highly valuable in identification work. CT scans and radiographs provide comprehensive imaging of both internal and external dental structure. Compared to surface scan, which only show outer feature, CT provide much deeper detail, which is crucial in identifying remains through bone and root structure. Artificial intelligence is now being explored to help automated dental comparisons. Machine learning and deep neural networks can analyze dental feature, detect distortion, and even flag inconsistencies. These tools can speed up the identification process and reduce human error, especially in mass disaster cases. Despite these innovations, forensic experts remain essential. AI cannot yet fully interpret complex cases, legal standards, or ethical consideration. Final identification must be made by trained odontologists who understand the context and implication of each finding.